I will start now. And I'm Heng from Ant Group, and we do LDBC benchmark and LDBC Financial Benchmark, and I will give introduction. And so I will go through the background, design, and the progress. At first, we know LDBC has SPB for RDF graph and graph analytics for graph algorithm benchmark, and SMB. It's for social network scenarios, and it's for property graph. And when I worked in Ant Group, and it's more about financial scenarios. Found it's the underlying characteristic will be different, and it has different requirement for the graph database. So we want to do this financial benchmark. And what is the difference? At first, the application scenarios is the difference. When we do SMB, it has something like a friend recommendation, and financial benchmark will be about risk control, anti-money laundering, know your customer. And so it results in the schema characteristic difference. And most of the time, SMB will have a single edge or a few edges, and financial benchmark will have multi-edge, because when we transfer money between two accounts, and we will transfer it many times one day, and when it is months, it was many edges. And also in an edge, it will have more properties. I will see a few hundred properties in edge. And it also will result in the workload characteristic difference. First is tight latency bound. When we do some online analytics, so a requirement is to have a round trip query less than 20 milliseconds. So it's very short time. And also in the query, it will have a read-write query, and temporal window, and subgraph pattern, recursive path filtering. I will give some examples for this characteristic later. So for financial benchmark design, or what we call FinBench design, and we have a very early draft, and we have here different vertex: person, account, company, and company long and median. So we have also different kinds of edges. So the solid anchor is about a single edge, but the dashed is about multi edges. We can see it has many different characteristics. I will give some details. So in the workloads, and we have TP workloads. It's tight bound, just said 20 milliseconds. And the query is something like interactive in the SMB. It has 1 or 1 to 4 hops, but the AP workload will be much more complex, and the latency is unlimited, and the query is also about interactive graph analytics. In this work, we'll start from the TP workload first, and the load definition can have strong transaction requirement and time to live data management, also pick and sort or carrier data influx. Here is example. We have read query in above and the write query below. So the read query can be very simple, like this, just extract account property query. And also it can be a few complex, like find a circle. It's a 3 count to 1 transfer money to B and A transfer money to B and B to C and C to A. It's a circle. Also, some right query. So it's when a transfer happens. So it is add an edge or mark an account as blocked. It's a property modifier. So in practical, the 3 queries can be composed to a read-write query. Here's an anti-money laundering case. So in this query, we have a transaction requirement. First, when the transaction begins, so the system will first check if the account is marked as blocked in the blacklist. So if true, the transaction will abort. When it's false, we go to the next step, and it's money transfer happened from this account to another account, and then the graph system should check if this transfer can happen to be found to be a circle. When we add this edge, it's the 3 accounts can become a circle. So when a circle found, it's mostly like someone is do some money rushing or something like that. It's not permitted. So if found, and it comes out to the true parts, and the transaction should abort. When it abort, this right query should not be submitted to the graph data system. And after abort, we will feel that this count has some problem and mark it in the blacklist. When when it is false, so the transaction can be committed. So in the financial scenario, we have some read-write query in a transaction, and also we have temporal windows. It's something like the Gabor introduced BI. When the financial scenarios, the query can only look in a temporal window. For example, it can look back 1 week or 1 month to this data is valid and it has more impact to the final result. So in this query, we have in each edge, it has a timestamp. It should be between start time and end time. So this is the temporal window constraints. And another is the subgraph pattern, like found some transfer circles or guarantee circles, and also sometimes when a guarantee found, it will become a long tree, so it also may have some problem. And in this one, it checked many transfer paths. So if the transfer amount be larger than a threshold, it may have some risk. Another thing I want to say is recursive path filtering. So what is it? And we see it is a wrong to account. After that, we should have multiple hops. This is the first hop, the second hop, and the third hop. And each different hop, we have some constraints. For example, the first hop constraints will be larger, maybe 50%, and the second hop it can be 40%. The constraints will be different in the recursive path filtering. It will define a path, and it will be different for different hops. And I think these are things different from the SMB, and so it is possible for us to define this financial benchmark. And the progress and the work chart has established. And currently, leader is Zhi Hui Guo. It's also from Ant Brook, and we have some friends from they also want to contribute from Intel, Katana Graph, Palm Tree, Altipa, Star Graph, Create Link, and Tag Graph. We will work together to do this financial benchmark. And currently, we have a very early draft. First is about schema, and we have introduced it. Also, we define some query we have 24 read query and 14 write query, also 5 read-write query. It is some draft from mostly from Ant Group, and we will check this query very carefully to see which one will be resolved in the final version, or maybe also it has some other opinions. And if anyone interested, you can find this draft in the public link. We have put the specification in the GitHub. And the progress, the financial benchmark proposal is proposed in February this year, but we have prepared this work last year and do a lot of pre-work. And member invitation is March and 4th April. In May, official announcement of financial benchmark has established, and we kick off just 2 weeks ago. In our schedule, we want to have a version in the end of this year. Here's some detailed schedule. At first, we should have a specification, and follow the specification. We develop a suite. It has data generation and driver, also reference implementations. I think the software is just like SMB, and we can have different graph systems to be tested. So this is the end, and we have just start our work and welcome everyone to join us. Here I list some useful links. If you are interested, you can find some useful info in these links. Thank you, everyone. Anyone has some questions?
Thank you. So any questions from the room?
Okay, I would like to ask some questions. So thanks for the presentation. So if I understand correctly, so this is very fresh work. This task force has just started. But if I understand correctly, you propose to have two workloads. One is called TML and the other one AML. Is that correct?
You mean TP and AP?
Oh, sorry, I got that wrong. Yeah.
So
Oh, yeah. TP
currently,
and AP.
we just work on TP first, and AP will be like BI in SMB, and it's not start yet.
Okay, so it stands for transaction. And what is the P? And analytical, I suppose.
Yes, we should have transaction in TP and AP. I'm not. It should be discussed later. So if it should has a strong transaction requirement or not.
Okay. Simple question. What does the letter P stand for here?
P, processing, just
processing. Okay, thank you.
Okay,
and,
transaction processing, analytic processing.
And you showed also some queries that look for circles. So that was a read-write query, I think. And if there would be a circle, then the query has to be aborted. Is that correct? And yeah. So I was there's a question here. So the circle that you showed was a direct circle. So it was a circle of length 2. Are you also considering circles of longer length, or is that because that would require path finding, whereas a circle of length 2 with a fixed length is only pattern matching?
I cannot quite get to your question, but if there's a circle, it can be the circle amongst accounts, also circle amongst let me see, it's guaranteed, so it may have different circles or chains. It will be different pattern, depends on the query. So the query must have some background meaning, anti-money laundering or know your customer, something like that.
Okay, well.
Am I answered your question?
Kind of, yes. Is there maybe in the meantime a question? There's a question from the room.
So there is a slides about the transactional queries, like 1 to 4 hops, I think.
Yes, I think I have introduced that we have total 24 queries. Each one has a transaction requirement, but the transaction may be different, just like this read-write query. It's a transaction begin or something. The transaction is abort. After the transaction abort, we have a write query.
Right. So my question is, like, you have a slides about TP and AP, and for the TP, it's 1 to 4 hops, and it's a kind of short queries. Is there a bias of supporting short queries better if we use this benchmark in that sense?
I cannot quite clear. So so I think this most of the TP workload needs transaction, whether it is 1 or 2 or 4 hops. So I write it here 1, 2, 3, 4 hops because to say it is just like interactive in the BI. So so hops will not be like unlimited to 10 or 20 hops, and it will be complete maybe within 20 milliseconds. It would have a tight bound.
Okay, so I was just curious if there's a bias here, like over short queries. That was my question. But thanks for the answer.
Oh, thank you.
Okay. Well, we are of course very curious what the final or what the first proposal is going to be, and also to the input of the other task force members. But thank you for this presentation. I think there are no more questions. Are there no questions online here?
Thank you very much.
Yes.
Thanks very much. That concludes the session. So see you after a coffee break.